I want to talk about risk and how you would measure risk. What I've done is I've gotten some prices here, and these are old prices, but this comes from a stock fund and a bond fund. So those are the prices. I want to figure out what the risk of, let's start with the stock fund, what that is. So how would I do that calculation? First, I need to find the returns. I never do it from prices. I do it from returns. So this number here is going to be the ending stock price divided by the beginning stock price minus 1. So I'm finding the holding period return, and notice that these are months. So this 10% increase is the 165 divided by the 149 minus 1. So those are my returns for the stock fund. So what I do is I say, how do I measure risk? And risk in this case is not how much you're going to lose, but risk in this case is the difference between what I actually get and what I expected to get. When I'm using historical data, which we're doing here, we're using historical data, we're saying what's the difference between the average return and what we actually got. So what we would do is we would start and say minus 0.0691 minus 0.0116. Let me show you where those numbers come from. If I average these four numbers right here, it averages the 1.16%. So I take each one of these numbers. That's going to be positive. In this case, the 1091 minus 0.0116. So everything that happened minus the average. So again, variance, our measure of risk we're going to come up with, is going to be the difference between what actually happened and what we expected to happen, or what happened on average. So it's important that you get that concept down. Now if I sum this up, what's this going to sum to? So I'm looking at all the deviations. Let me give that a name. These would be called the deviations, because how much does the actual event, the actual return, deviate from the average return? So those are the deviations. If I sum those up, those will always sum to 0, and I haven't done anything. The way to think about that, if I told you the class average on the exam was at 85 and you made a 90, you would have a plus 5 deviation. Your friend made a 75, he would have a minus 10 deviation. So if I add up all the points above the average and all the points below the average, by definition of average, they come out to be 0. So what I do to keep these from being 0, I'm going to square them. So all these terms are going to be squared. I could do the absolute value, but if I square them, I'm going to have the distance between what happened and average. So I sum these up, and then people do this different ways. We're going to divide by n minus 1. And sometimes people divide by n, and it's not going to make a big difference, but let me tell you what's technically going on here. Is this number the average? And my answer to that is no, this number is not the average, because I don't have every return for the stock fund that ever existed. I only have returns for the stock fund over these dates. So this is an estimate of the average, not the actual average. So when I'm subtracting the estimate, not the truth, I lose a degree of freedom. So bottom line, I divide by n minus 1. That is going to give me the variance. That's always written as sigma, lowercase sigma squared, and subscript, I could write S for stocks. Okay, so if I take the square root of that, so the square root of the variance is called the standard deviation. Because think what you have here. You have all the deviations. I'm essentially getting the average of those deviations. It's called the standard deviation. Sometimes people call it the volatility. What I want you to think about is go back to your stat classes, and let's see if I can draw this somewhat okay. If I have a normal distribution, just pretend that's a perfect bell curve. You would have the mean, which would be 0.0116, and then I would add the standard deviation. So this would be 0.0116 plus the standard deviation, which came out to be this number. Well, that's annualized. I'm sorry, I circled the wrong number. Which would come out to be this number right here, 0.0638. Or I could go to this point, 0.0116 minus 0.0638. I know that approximately 68% of the time I'm between plus or minus 1 standard deviation. So that's why I'm coming up with standard deviations here. You know, in 2 standard deviations between that 95% and 99%. So that's the measure of risk that I'm getting for the stock fund. I could do the same thing for the bond fund, so let me get rid of all this stuff. So I want to redo the variance for the bond fund, so I want to look at these returns. Let's take 0.0282 minus its average, 0.0189, and I'm going to square that. And I take 0.0433 minus the average and square it, and negative 0.0378 minus the average and square it, and then 0.0416 minus the average and square it. Sum this up. That's the sum of the squared deviations. You have the deviations, you square them, you add them up. It's the sum of the squared deviations. So sum of squared deviations divided by n minus 1 is equal to the variance of the bond fund, which is equal to this number right here, 0.0011. Take the square root, and the standard deviation is equal to the square root, which is 0.0332. Okay, so next I want to talk to you about how to annualize these, because I always want to have this stuff in annual terms. So if I have the expected return of 1.16% and I want to annualize it, and it's monthly data, I multiply by 12. If I want to do the same with the variance, it would be 0.41% monthly data times 12, and that would equal the annual variance. So I want you to look at this way. If I have the annual variance is equal to the monthly variance times 12, then the standard deviation, I take the square root of both sides, the annual standard deviation is equal to the monthly standard deviation times the square root of 12. So make sure you can annualize those. So make sure you can get, at this point, you should be able to get these returns and annualize them. You should be able to get the variance and annualize it, the standard deviation and annualize it, all those numbers. Now I want to go to the next thing. So we have the risk of each individual asset. So if you look at it this way, here is the risk of each one of those individualized assets. I want to see the relationship between the two. So I want to see how they move together. So I'm going to get a measure called the covariance to see how the stock fund and the bond fund co-vary. And this is going to make a lot of sense on how to do this. You do the exact same thing you would do to get the variance of the stock fund, which is negative 0.0691 minus the average 0.0116, and then let me make sure I'm in the right spot. Not 0.1091 minus 0.0116, and minus 0.0041 minus 0.0116, and then 0.0103 minus 0.0116. So those are the deviations for the stock fund. What I want to do is then multiply that by the deviations for the bond fund. So the bond fund, you have 0.0282 minus its average, 0.0189, 0.0433 minus its average, 0.03, it's a negative, 0.0378 minus 0.0189, and then 0.0416 minus 0.0189. I sum this up, divide by n minus 1, and this is equal to my covariance, which is represented as sigma subscript s comma b. But look and see what this is doing. It's saying, did the stock fund, how did it perform relative to its average? It was below its average, okay? And the bond fund in that same month was above its average. The next month the stock fund was above the average, so was the bond fund. Here they were both below. Here this one was barely below, that one was above. So getting this covariance is saying, how did the stock fund outperform its average, and at the same time what did the bond fund do? So we come up with a number for that, and that number is going to be 0.0075. That number doesn't tell me very much. I know it's positive, so I know the two funds move together, but I don't know exactly how they move together. So I come up with a correlation. That's the Greek letter rho. Correlation of S and B is equal to the covariance of S and B divided by the two standard deviations. So it's equal to 0.0075 divided by 0.0638 times 0.0332. So it should be this number, and this number. That's going to equal 0.29. Now this tells me information, because I know correlation is always between +1 and -1. Get that fixed. Correlation is always between -1 and +1. If correlation is equal to 1, that means they move together perfectly. It's very important to get it. They move together perfectly. If it's -1, they move together in the opposite direction. 0, then they're independent of each other. The whole point of what I want to do here is diversify. So if I have two funds that have a correlation of 1, I have no diversification. If they have a correlation of -1, if I do things right, I can have perfect diversification. So in this case, we have a correlation of 0.29. That means I get a lot of diversification. They move together some, but not a lot. So that's the way to think of it. So this is getting variance and covariance and correlation from historical data. Next we'll do it a slightly different way.